This conference will now be recorded.
So in the first class, we have taken introduction about. Please be fast. Okay, sir. Till now, I have taken 2 sessions on the reinforcement learning. Array, ma'am, please. Okay. In our oral session number 1, what we discussed, sir? So the style of learning in machine learning and deep learning, the 3 approaches like supervised learning, unsupervised learning, reinforcement learning. So how exactly the supervised learning will work, which learns from the data by using both features and labels. But in case of unsupervised learning, learn from the data only, but no labels, only features. But in reinforcement learning, you don't learn from the data, you learn from the environmental rules. If you are an agent, you learn from environmental rules. So in the second session of oral, so we discussed about the key terms of oral. As who is the agent, who is the learner? Agent. Learn from what? Environment. In fact, this is the environmental rules. These environmental rules has 3 spaces.
State,
State space, action,
action, rewards.
so these are the things. So programmatically to define this, the environmental rules should be in the form of a matrix. Matrix have 3 things here: states, action, rewards. You should define states as rows, actions as columns. Each cell is a reward. Today we will learn how to create your environmental matrix from a data file. So what is the shape of data that you get for an environment? So at that point we will learn it. Once that data preparation for any model, sir, not only in reinforcement learning. Go for machine learning, so supervised or unsupervised, deep learning, supervised or unsupervised. So finally, before you train your model, you have to prepare your data. If data preparation is wrong, total learning will be wrong. So as a first part, data cleansing and data preparation. In the case of ML, there is a life cycle. First we extract data. After that, data cleansing, transformations, and then model selection. Then model selection, then training model. After training model, evaluation of the model. That means accuracy testing. Then finally, if you satisfy with the accuracy, you will deploy the model. On such way, reinforcement learning has a special mechanism. First of all, you have to prepare environmental matrix, then knowledge matrix, and then finally train the agent. Within the agent, you will plug in within the training path. During the training path, you will plug in Q-learning equation. In the beginning, the knowledge matrix of your agent is 0. But after completion of the training, the knowledge matrix got filled with a rich set of values. So finally, whatever agent is going to learn is the best policy. Best policy means a lot of actions are possible, which is the right action at a right moment. That to optimize you. So you have seen in the previous explanation of last class. To reach, suppose if you are in room number 0, to reach the goal state as room number 5, in so many ways that you can reach. Among all the ways, each way is called as a policy. Among all the ways, which is the best policy? That means optimized policy. In this context, what do you mean by optimized policy? Less cost or less time. Within a short span of time, with less efforts, your agent has to reach your goal state. Okay, so that's what like finally your agent is going to learn. This knowledge you can use it for a simple problems, you can use for a complex environmental problems. The problem is too much complex. Same reinforcement learning you use with deep learning. The integration of this deep learning and this reinforcement learning is called deep Q learning. Got the point? So first, once you got a grip over the reinforcement learning mechanism, programmatically and theoretically, then easily you can understand deep learning's deep Q reinforcement learning. Today our target is how to create environmental matrix from a data file. Okay. So two ways, in different ways you will get data files. Whatever the way may be, you should be able to finally create environmental matrix. So at least today, two ways we will see, and the next class, the third way of data file also I will show you. Got it? All of you put the heading. Sir, please, too much you are doing daily. Whenever I am starting something, you people are opening the door. For later we will discuss, sir. We are in the deep session. Okay, later. Okay. All of you put the heading. With Python. So the new guys who don't know Python, please follow my Python recorded sessions, which are available in my LMS application and the same time parallel available in YouTube channel also.
Please mute your mic sir, if you are not talking.
Pardon?
I'm getting huge noise. Someone is on unmute.
Voice is breaking, sir. Can you type?
Few people are on unmute. I'm asking to mute their mics.
Yeah. All of you go for mute, sir. The steps in this implementation. The step 1. Read data from file or any other source. Step 2. Create environment matrix. Or simply you can say it as a rule matrix also. Step 3. Create knowledge matrix. What is the symbol for environmental matrix? It's not rule, just you follow some recommendations, standards. Create environment or rule matrix. Create knowledge matrix. Step 4. Trial agent. And step 5. Test agent behavior. And step 6. Deploy agent. Result with e-rules and a trained queue. So these are the steps you need to follow for every program. Okay. Today our targets, the first 2 steps of this week, Python implementation. All of you completed this? Keep it like this one. Come on, have a heading. Different data sources for your environment. What is the first shape you just check it? First of all, have your picture of your environment. So the previous explanation environment I am giving you. This is outer space. It is simply called as goal step. The room number 0, 1, 2, 3, 4. Where is the vacancy, sir? 0 to 4, 4 to 5, 4 to 3 and 3 to 4, 2 to 3, 1 to 3, 1 to 5 vacancies there. Think that these are the vacant doors, or open doors. It's a simple environment. Once you understood this, let's make this as a complex environment. So by seeing this picture, you have to construct your rules file. Generally, rules file will be directly given to you. Who will create the rules is a domain expert will be creating the rules, not you guys. Okay. Suppose it is about a finance domain, about some financial activity of trade transactions like that. The domain expert of that stock, he will create the rules. Okay. According to those rules, you need to prepare your matrix. So very simple way of data file preparation, rule file preparation, how the consultant will give you, just see. How many states are here? 6 states. How many actions? 6 actions. Luckily in this example, number of states, number of actions are equal. That's why you will get a square matrix. But in lot many cases, number of states and number of actions are not equal. Understood? So those examples also we will see. First we go for a simple way. This is what our picture. Later in a Word document, I will copy the pictures. Just for my remembrance purpose, here I am adding. Later I will add the picture here. In this case, what is the behavior? Number of states, 6. Number of actions, 6. And also one more behavior you can observe. The label of state equal to label of action. But in so many cases again, the label of state is different. The label of action is different. For this very beginning example I told you, a red light, what is the possible actions? Stop and move. Now the label of state is different, label of action is different. But here all the states are rooms, actions are rooms only. Understood? If it is the case, like how will be the environmental matrix, we see first. The environment matrix shape is like this. Come on, all of you, observe this. Imagine the matrix in a row and column wise. 0, 0. What do you want to give? Minus 0, 1. No vacancy. Minus 1. 0 to 2. 0 to 3. Minus 1. 0 to 4. Vacancy is there but no result. So that's 0. Next 0 to 5. Minus. Okay, come to the room number 1, sir. State number 1. Just once again have a look. Now if you are in room number 1, what you can do, what you cannot do. Please verify. Come on, tell me please. Start from 0. 1 to 0.
-1.
1 to 1.
0. -1.
1 to 2. 1 to 3.
-1.
1 to 3
0.
vacancies. But no result. 0. 1 to 1. 1 to 4.
-1.
1 to 5.
-430.
There at the same time 5 is your goal state. You can apply highest reward. The highest reward is here.
100.
Look the state number 2, sir. This is state number 2. Based on this, always keep the picture in the mind. 2 0.
-1.
2 1.
-1.
2 2.
-1.
2 3.
0,
2, 4,
minus 1,
2, 5,
minus 1,
Now come to the state number 3. Ready? Please. 3, 0,
minus 1, minus 1,
3, 1,
0,
3,
0,
2,
0,
3, 3,
minus
minus
1,
1,
3, 4,
0,
0,
minus 1,
3, 5.
0,
Already you know the structure of 4. Tell me. 4, 0.
0,
That's why I will open the picture now. I believe your strongness of your brains. Okay, once again imagine the picture. Now we are in room number 4. Come on.
0,
4, 0, 0,
minus
4,
1,
1,
minus 1,
4, 2,
minus
minus
1,
1,
4, 3, 4,
0,
4,
0,
minus
5.
minus 1,
Target
100,
state. Okay.
100,
100.
Ready? Now come to number 5. Already you are out of jail now. I am asking you go to the jail. Up to now observe sir. 0, 0 minus 1. 1, 1 minus
minus
1. 2, 2, 3, 3, 4, 4. For all these things minus 1. But already you are out of jail. I am going to I am asking you go to out of jail. Where you have to be? You have to stay at 5 only. Now in this case 5 to 5 means that is 100. Like this, come on, plan it. 5, 0,
1, minus 1,
5, 1, 5, 2,
0,
5,
minus 1,
3,
0,
5, 4, 5, 5.
0, 100,
In this way you will get the data instructions back, the rules back. Of course, for this content, you will get one more description of the rules information. So what are the rows, what are the things like that. In this way you will get a fact. Girija, stop writing and listen. Otherwise I will take a hand over your notes. Okay, the file name, let's give rules 1 I am giving. It's a simple rule file. Just copy for notes purpose. Not here, right? The file is rule 1.txt. I'm copying the content here. It's all just for your notes. Come on, all of you take 1 or 2 rows of sample of this environment. Please don't take all the rows, just take 1 or 2 rows, remaining say dots. Right. So from this file, how to create our environment matrix fields. Now coming to the Python. First I'm going to read the file. I'm creating a file object. There is a file path we have given, sir. Nice stuff. In my regular directory, I will save it. Under D, I have a directory my stuff. Another file name is tool1.txt. The default mode is here read-only mode. I don't have any header in the file. I want to read all the files, all the lines of the file. F.read lines. Right from the line 1 till last line, it will read all the data. Each line has an element here. No such file directory messed up groups. I think the rules 1 we have set. Over here, each line has an element in the list. Whenever you press enter key, here \n is recorded. But that is in the string format, you read in a numeric format. So now the processing. Make an empty list. Initially small e I am giving as an empty list. Each line I am processing from the lines or line in lines. I have 6 elements, loop runs for 6 times. Each line I am splitting line dot strip first. The strip elements eliminates left side, right side white spaces, including invisible characters like \n, \t, such kind of invisible characters also. After elimination of that, I'm splitting. What is the delimiter between each element? Now, just up to now, we test the value of it. Understood? Each line is split into a list. The list has again 6 elements. But we need it as a number. Capital W I am giving. The for loop transformation style. Expression. For loop. What is my for loop? For V in W. W has 6 elements, loop is running for 6 times. At each iteration, each value is coming into V. For that V, what you want to do? I'm just in the place of expression I am giving int of V. Now each value is converted into integer. Just once again, please type it. Previously string, now each element is a number. Okay. Now in the first iteration, I'm working with this element. That element will split it here. After that, each value converted into integer. If there are float values, convert into float. Generally, states and the actions are not in the format of float. They are in integer format only. I'm adding this W into E. E is already listed, W is also a list. Now finally, after appending this, E become list of list. Simply how to add? E dot append of capital. After completion of this loop, just verify the data and shape of this E. Now is a list of list or not? List of list means that is a double dimension. List is single. List of list is double dimension. List of list is triple dimension. Like this. But mostly like in machine learning, deep learning, reinforcement learning, you go for anywhere. You work with matrices. Matrices means linear algebra. Linear algebra computations we need to do, not statistical computations. So that's why I will convert it as for the linear algebra in Python. You have a module called NumPy. If it is NumPy, all matrix related, linear algebra related, predefined functions are available. For example, this is one matrix. Without NumPy, you want to perform matrix multiplication. You need to write 200 lines of code. In some other case, you want to use matrix inversion. Too much biggest code you need to write. But if I go with the NumPy module of Python, all matrix related computations, simple and complex, and all linear algebra mathematics, with predefined functions you can perform. So you need not to worry about the how to compute the mathematics of those things. But you should have the clarity when to use matrix multiplication, when to use inversion, when to use transpose. Totally your journey with only these three things. You know, multiplication, transpose, inverse. If you know these three, any kind of complex mathematics you can understand in the reinforcement. Okay, that's why I'm going to convert that E into NumPy matrix. To make it as NumPy, I'm taking capital E equal to my NumPy object is NP dot array my small. Previously E is a list of list which is normal Python core object. Now here capital is a NumPy object, NumPy matrix object. But we need to import that NumPy. Import NumPy. I'm giving one alias name for this. This alias is acting as an object. That object has a method, that is function as array, which will convert list of list into NumPy array. Now check the value of this E. Print capital E. Now is a matrix or not? This should be the shape of your environmental matrix. With same size, you have to create your knowledge matrix also. For this title, I am coming to the knowledge matrix. Before that, one simple practice example. Already I have NP. Okay. E is my NumPy array. Dot shape. The shape will give you dimension. 6 by 6 in the form of a tuple. That means 6 rows, 6 columns. What is the index number? 0 to 5. Column wise 0 to 5. Got it? So indexing starts from similar to Java or JavaScript. Indexing starts from 0 1. But if you go for R language, such kind of languages, indexing starts from the 1. In R language also you have different packages for the reinforcement learning, but those are not effective. So complete statistical analysis wise you can use R language. But complex implementations like machine learning, deep learning, reinforcement learning, you cannot rely on R language. The only choice is Python. Okay. So now I'm going to create my knowledge matrix. Observe this. For the knowledge matrix, I am doing the shape. Initially all values zeros. because this is the activity before training. Before training, the knowledge is zero of your agent. NP dot zeros directly function is there. NP dot zeros how to give the shape. My shape is here. Observe here. What are the size for environmental matrix? Same size for Q matrix. 17 plus 2 meter.
So much disturbance is there, sir.
Online team, go to mute because not only you are attending class, other people also attending the class. Please adjust. Okay, come here. I have to give the shape in the form of a tuple. 6 rows, 6 columns. But in this case, 6 rows, 6 means that is hard coding. Whatever the shape we have for the environment, same shape should be for in the place of 6. I am giving here E dot shape. Now check my values of Q. Print Q. Now what is your understanding? Before you start your process of training, you have to prepare two matrices. One is E, second one is Q. In the beginning, Q is zeros, all values zeros. After training, the values got filled with the best policies. Finally, after completion of the training, your agent takes action based on the values of this Q. Okay. So now we are in the phase of how to prepare the data. Later we see how to train the agent. Got it? Come on, all of you take this. Already have taken file content, right? 1 minute, I will copy this. Come on, take it first. Online team, please take a note. Next, please don't take outputs. Take only the code. Okay. Next. Then the last, knowledge matrix. This is what how to prepare our E and Q. These are the two steps common for every program. Put the heading column with about data. About data file. Which is a file one.txt. Sorry, rules one, right? In a complex environment, millions of states and lakhs of actions are available. So rules file may occupy TBs, that means terabytes of data. In such case, distributed systems are used. Distributed parallel processing systems are used. To read and process the data. What are the examples of distributed processing parallel systems? Hadoop, Spark, still lot others, but these two are popular. Parallel processing system. Whatever you said that is horizontal, that is scaling type. I'm talking about processing type. Horizontal, vertical. Vertical means single CPU. Horizontal means collection of multiple CPUs. That means a cluster is acting as a server. Suppose your single system can load up to 1 terabyte, means if I give you 100 terabyte of data, you cannot maintain that. So for that purpose, like distributed parallel systems in the style of horizontal scale. That means if the space not sufficient, you will be adding few more nodes. So such parallel systems are used. The popular examples for this Hadoop and Spark kind of things. So for these systems, compatible data is below. State 1, action 1, reward, reward. State 2, sorry, still state 1, action 2, rewarded 2. State 1, action 3, reward 3. So above is style of sparse. Understood this? Because in the distributed systems, the data has to be distributed into multiple systems. If I keep above shape, suppose the first 10 rows, first 10 columns are distributed into one system, next 10 rows, next 20 columns distributed into another system, the matrix computations will be false. Now in this case, the row-wise splitting is required, not column-wise splitting. Row-wise splitting is required. That's why you are converting entire matrix into the sparse shape. That means a row number, comma, column number, comma, reward cell value. Again, same row, next column, the reward value on the tree. So for this, what exactly the data shape we will see. So this kind of style is better fit for parallel systems like Hadoop and Spark. So example for the like a complex environment is Google driverless cars. Lakhs of rules, that to millions of states, lakhs of possible actions. Understood that? So in such case, you cannot go into a boast. Simple game you can go, but in the same thing in the games, you want to make like the game PUBG as artificial intelligence game is a lot complex environment. For such kind of things, you cannot go into the first style. The second style is recommended. All of you understood this. Now, how will be my data? You just check it now. Room 0 to room 0. Reward is -1. Let me take risk of the preparation. Now I can say, right? 0 to 1, -1. In this way, string labels will be given to you, not the numeric labels. But challenge how to convert these string labels into numeric content. That way as rows and columns. Room 3. Room 4. 0. Room 5. Minus. This is the shape. So can keep the same thing for 1. This is -1, right? Come on, 1 to 0, 1 to 1, 1 to 2, 1 to 3. 1 to 4, 1 to 5. This is the shape. Same thing, do it for the room number 1, room number 2. Come on. 2 to 0, minus 1. 2 to 1, minus 1. 2 to 2, minus 1. 2 to 3, 0. 2 to 4, minus 1. 2 to 5. Come on, please. 3, 0. Minus 1, 3, 2. 3, 1, 3, 2. 3, 3. 3, 4. 3, 5. The last. Same thing for the fours. What is the data set? 4, 0, 0. 4, 1, minus 1. 4, 2, minus 1. 4, 3. 0, 4, 4. 4, 5. The last state, which is about number 5. 5, 0, 7. 5, 1. 5, 2. 5, 3. 5, 4. 5, 5. This is tile number 2. Understood this? If there are 10 systems in the distributed systems, some 100 rows will be into system 1, 100 rows will be into system 2, 100 rows will be into system 3. On that way, data will be distributed into parallel systems. Now no columns will be missing. Understood? All the data is available in multiple machines. Because if the volume is very bigger, you cannot keep all the data into one single machine. Understood this point? Like this. But this is like a complex structure. For looks, it is simple structure. For data preparation, a lot manipulation in. So how to convert this data into matrix? That is a challenge. This is style number 2. Style number 2. There is a style number 3. That also I will show you. So let's say rules. 2. Rules 3. The shape is like this. 0 to 0. Vacancy is there or not? 0 to 0. Vacancy is there. But it should not be. Understand? It should not be. How to explain? It should not be in the form of label. No. Currently, if you are in 0 means in the next moment you should not be in the 0. That is what the meaning of it. Okay? And now 0 to 1. No. 0 to 2. 0 3. No. 0 4. 05. Understood. Almost all the values are no's. If you are in 0 to 4 vacancy is there, right? 0 to 4 vacancy. On that way, instead of giving the rewards, they are just giving you which door is open, which door is locked. This is more complicated than the second one. Understood the points? So how you get in the industry, how you get in environmental rules is in this shape. In the style 2 or in the style 3, not in the style 1. Sir, one company is using artificial intelligence means that is basically data entry centric company means that is basically big company. Obviously, they have big data. Understood. At that moment, old techniques will not work. Same styles are remaining same style. You tell me for the last. Observe this. Whenever they achieved goal, they will say it as a goal. Understood. Here, no vacancy. Here, yes. Here, no. Here, no. Here, yes. Here, 5 is a goal, but no vacancy from 3. That's why no. But here you observe 4 to 5, vacancy is there, but we achieved the target. That's why go. On that way, the file will be given. How to convert this kind of file into your environmental matrix is a little more tough than style number. Okay. So in the coming 2 classes, we will be learning style 2 processing and style 3 processing. Don't worry about the coding. I will give you the tips about this. Once you practice that automatically, parallelly, along with the reinforcement learning, you will be strong enough into Python. But you start your work about my Python videos if you are new to the Python. Okay. Last shot. Tell me for 5, sir. No. Yes. No. No. Yes. 5 to 5. Good. If it is goal, no need to do anything. Understood this. On that way, the information will be given. After completion of style 2, style 3, I will give you one more style. Okay. In so many ways, you will get your environmental tools. Whatever the style may be, you could able to do that. Got it? Take style number 3 also. Style 2 already have taken, right? No, I think no. Just a minute. Rules 2. This is style 2. Please take 2 states remaining same dots, please. Okay, can I go to the next step? File name here, rules 3. Take last few rows, especially which covers number 5. Rule number 5. Take rule 4 and 5 states. Okay, sir, our target in the coming 2 days. Tomorrow, the style to conversion. Tomorrow, date what's the 8th? 9th. Okay. On 9th, the style to conversion. On 10th, we will learn a last style 2. And also, I give you one more new style. In different ways, you can get the data. Okay, about the rules. Yeah. Let's see tomorrow, sir. All of you. Yeah, here Santosh has a question. Don't we get the float values? Can't we convert into the float instead int? Generally, state and actions will be into int, sir. Only rewards can be into floats because you are keeping state as row number. So row number should not be a float. Column number should not be a float because for the matrix, row column should be indexing starts from what number? 0. What will be the next index? 1. Next index 2. Like that. Okay. Rewards can be float or int, but state and action should be integers. Understood? Santosh.
Okay.
Bharat